Hello friends. Now let us take an example where we will trace a curve in parametric form. Now this is an example of a typical curve called as a cycloid. So basically what is a cycloid? Cycloid is a you can say a path traced by a fixed point on a wheel or a circular wheel. When that wheel you place on a plane surface. So when you put a wheel on a plane surface, okay, a fixed point will trace a path called as a cycloid. We'll see what this curve looks like. So let me take the first example of this cycloid. And so x is equal to a into theta plus sine theta, and y is equal to a into 1 plus cos theta. I'll call this as 1 and 2. So this is a curve represented by this equation 1 and 2. Here theta is a parameter. Okay. So we'll start tracing this curve. First point we'll take as the symmetry. Right. Now here you have observed that here x is equal to f of theta. Okay. Where f of theta is this, and y is equal to g of theta, where g of theta is this. Okay. Now if I replace theta by minus theta, so replace theta by minus theta, what we will get? So f of minus theta will be a into minus theta plus sine minus theta, that is equal to a into minus theta minus sine theta, that is equal to minus a into theta plus sine theta. So it is minus of f of theta, right? So f of minus theta is minus of f theta, and g of minus theta will be a into 1 plus cos minus theta. So it is a into 1 plus cos theta, because we know that cos of minus theta is cos theta. So it is g of theta. So see that this f is an odd function and g is an even function. Okay, what it means? It means that the curve is symmetric about y-axis. Okay, we have just seen the rules that f is even, f is odd, g is even. In that case, your curve is symmetric about y-axis. Okay, so this point we have done. Next point, whether the curve passes through origin. So you look for a value of theta for which, if you substitute that theta in both these equations, a single value of theta, both x and y is going to be 0. Okay, and you can try for certain thetas, say theta equal to 0, pi by 4, pi, 2 pi, etc. You will see that there is no value of theta for which both values of both x and y is equal to 0. So observe that for no value of theta, x equal to y equal to 0, right? And therefore the curve does not pass through origin. So origin se passing through. So it is not passing through origin. Okay. Now what we have obtained so far, the curve is symmetric about y-axis and it is not passing through origin. Okay, fine. Now we will obtain the formula to calculate the slope of the tangent to this curve at different theta points. So my next point is to get dy by dx. So third point, find dy by dx. And now see that the equation given in parametric form. So what is the formula for dy by dx? It is dy by d theta divided by dx by d theta. Okay, and what is dy by d theta? So that is obtained by differentiating equation number 2 with respect to theta. So it will be minus a sine theta, isn't it? And what is dx by d theta? It is 1 a into bracket 1 plus cos theta. So this a get cancelled, right? And if you replace sin theta with 2 sin theta cos theta, so if I write here 2 sin theta by 2 cos theta by 2 divided by 1 plus cos theta is 2 cos square theta by 2. So 2 get cancelled, one of the cos get cancelled, and we will get, of course, this minus sign is here, minus tan theta by 2 as our dy by dx. So dy by dx is minus tan theta by 2. So this also we have obtained. Fine. Okay. Fine. Now what we will see is okay. Now let us form a table. So we have almost traced every point. So let us form a table. So this is important thing, table. I told you that in parametric form we need this table. Okay, this table will contain the values of t, x, y, and dy by dx. Right? I can give this as equation number 3. Okay, so not 3. We have parameters theta. So theta, x, y, and dy by dx. Okay, so let us form this table over here. Theta, x, y, and dy by dx. Right? So for different values of theta, now let me put this. So I'll take the theta to be equal to pi or minus pi, 0, pi, and say 2 pi. Okay, you can take different points, not like this only. Maybe minus pi, then pi by 2, then 0, pi by 2, pi, and so on. Okay, so some values are on opposite side. We have taken. Okay, so if I put theta equal to pi in equation 1, 2, and 3, what I will get? Okay, let's see. Suppose I put theta equal to minus pi here. This will be 0. This will be minus pi. This is minus a pi. Okay, and y will be here cos of minus pi same as cos pi. So it will be minus 1 plus 1, 0. So y is 0. Right? Then dy by dx, if I put here minus pi, it will be minus pi by 2. Negative sign is outside, and tan of pi by 2 is infinity. So this is infinity. Right? Okay. 0. If I put 0, this is 0, this is 0. So this will be 0. Why? 1 plus 1, so this will be 2. Okay. Then dy by dx, 0. So it will be 0. Then pi. If I put pi here, sin pi 0. So a pi. And if I put pi over here, it is 0. Okay. Pi here, it is minus infinity. So basically the slope is infinity. That's it. What we want is. Then 2 pi. Here 0. This is 2a pi. Okay. Then y, 2 pi. Cos 2 pi is what? Cos 2 pi is same as cos 0. Cos 0 is what? 1. 1 plus 1, 2. Okay. And when we put here tan pi. Okay, so what is tan pi? Right? So tan pi will be sin pi upon cos pi. Cos pi is 0, sin pi, so it is 0, right? So we have got this table. Okay. Now looking at this table and the previous information, now we are able to draw our curve. So let's draw our curve. Okay. Fine. So let us draw this curve. So this is x-axis. Okay. Here is origin. Okay. So this is origin. Now we have taken different points. So what we will do is here I will take minus pi. Here is plus pi. Then 2 pi. And if we extend here, this is minus 2. Right? Now it is symmetric. So whatever you draw on this side, you can simply make the inverse image of this, a mirror image of this over this side. Now see at 0, what is happening? Your x coordinate is 0 and y coordinate is 2a. That means when theta is 0, you will be here somewhere. This is 0, 2. Right? And at that point, the slope of the tangent is 0. That means the tangent, if I draw at that point to the origin, to this point, to the curve, it is parallel to x-axis. The tangent is like this. This is the tangent. At 0, 2a. So it has to be like this only. Okay, the curve has to be like this. Fine. We'll see what happened to when we'll come to pi. So when we'll be at pi, okay, x coordinate is a pi. So a pi is somewhere here, a times pi. Let me take a times pi over here. Right? And here also minus a pi. See that when it is minus pi. Okay, so I'll call this as a pi. This is minus a pi. And then this will go like this. Like this. So this becomes the cycloid. So whatever, this is a periodic function now. So whatever happened in this particular period will be repeated on this side, will be repeated on this side. Okay. So basically you will get a curve like this finally. Okay. This is at origin. This is the position. So you are getting a curve like this. Fine. So this is a cycloid. Okay. I hope you have understood this part. Just go through it once and we'll see some more examples in the next video. Thank you.